Mm, is anyone there? So last time I have shared some question to you. So perhaps it's a long time, 1 week after. So anyone has tried or hello?
No, sir.
I was not there, sir, in last class.
Mhm. So anyone from last class who is available that time and tried? Hello.
Yes, sir.
Yes, sir.
I had tried.
Okay. I will wait. Read this question first, and after 2 minutes we will start. Okay.
Yes.
I hope that formulas and all you might have remembered. Huh?
Yes, sir.
So keep the calculators along with you, and I will ask the data to from you people. Okay.
Sir, what is this Jamboard?
Which board you are seeing?
Sir, you have shared the something, sir. Hello?
I haven't shared anything. So
Yes, sir?
someone other people I might have shared. I think
Okay, sir.
you will see
Okay, sir.
later what is it. Okay,
Okay,
we will
sir.
solve this question first.
Sir,
Okay.
sir, I can ask one thing.
Yeah, yeah.
Sir, I have opened the portal
Mm-hmm.
now itself.
Mm-hmm.
Sir, there is been given some 15/8 2022 this class 2020 22 08 20 means today's क्लास शो सर जो 15 अगस्त की जो क्लास है वो हम रिवाइंड करके देख सकते हैं सर नहीं वो खुल नहीं रहा सर
Actually, I don't know which portal you are asking about. One
है
minute.
सर
1 minute. 1 minute. What you are
हाँ
saying?
ये वाला सर जो 15 अगस्त वाला सर इसके बराबर हाँ ये वाला ये दे रखी है ना सर
Mm-hmm. I think there is some mistake from their point. They forgot to. They completely put the whole subjects here. What I am going to take. So maybe it's their mistake from portal side. So these are the
सर
total
व्हाट
subjects.
अबाउट
So actually, I haven't filled this part. So they automatically took the whole subjects. Initially, this point of time, they have changed the portal a bit. So now what they are doing, they used to put the topics what we are going to take next classes like that. So might be from their point of mistake from their
सर ने
side.
मीन्स अभी जो आप लाइव सेशंस की जो रिकॉर्डिंग है वो तो आएंगी ना सर
They will add here some link they will attach here and that there they will attach. So they are keep working on that.
ओके ओके सर
So here you will
ओके
get the recordings and all whatever will be there.
ओके सर ओके
Okay then so we will start. First you tell the data. Okay, I will keep on solving here. So first we will write the given data. An ideal gas is heated at a constant volume until its temperature is 3 times the original temperature. So first of all we will write the all given data here. Actually this is the conventional problem. So with one conventional problem you will get the actual feel like how to implement the things here. So it would be better to go with the conventional one. So here we will write the constant process they have mentioned ideal gas heated at a constant volume. So volume constant they have told and its temperature is 3 times of the original temperature. So when we will try to make the PV diagram. So temperature is 3 times of original temperature. So what anyone can tell what happens when volume is constant and temperature is heated?
The
Hello.
pressure will
It
increase.
increases.
Pressure will increase,
So
and
pressure will increase.
how it will increase?
Uh, Directly proportional to temperature.
It will be P directly proportional to temperature for the constant volume process. Okay.
Instant volume process.
So at a constant volume until temperature is 3 times of original temperature, means if we take this process and this is point 1 and this is point 2. Okay. So this P1 and P2, and we know the P2 is 3 times of P1 now, right? Hello.
Yes, sir.
Yes, sir.
Sir, yes, sir.
Mhm.
Yes, sir.
So now they told like then it is expanded isothermally till it reaches to original pressure. So when it will expand, then the pressure will drop, right?
Sir, please speak shabd loudly, sir. Not hear your
Okay.
voice.
Hello. Am I audible now?
Uh,
Yes,
Yes,
sir.
sir.
yes,
Yes,
sir. You
sir.
are
Audible.
audible, but please speak loudly a little more.
Okay. Okay. 1 minute. I think here's some problem from this side. Hello. Now fine.
Yes, sir. Yes,
Yes,
sir.
sir.
You
You
are
are
audible.
audible.
Hmm. So from this they have expanded isothermally, and its pressure will decrease. This will go this way and this way. Here volume constant and here uh, temperature constant, right? And till it reaches to the original pressure. So we have expanded when this P3 is equal to P1. Sorry, one. And then gas is then cooled at constant pressure. So when at constant pressure gas will cool, volume will decrease, right? So
Yes,
it
sir.
will come to the original state. So this is our actual cycle. So uh, it is the clockwise or anti-clockwise? First tell this.
Clockwise.
Clockwise. And any
Sir, it is clockwise.
PV or TS, any cycle if
This
the
clockwise.
if clockwise, then remember it would be the work producing cycle. Okay, work producing cycle. And if it would be anti-clockwise, then
Consume.
Not absorbing cycle.
uh,
Sir, work doing cycle it is.
so it will be
Excuse me, sir.
example for that. Anyone can tell?
Consuming, sir. Work consume.
Work
Work
consuming.
consuming.
Work.
Refrigerator.
So for that PVTS, we might have seen that auto cycle, Brayton, Rankine, whatever engine and whatever cycles are that clockwise, those would be the work producing, and we will be getting work out of that. We will give some heat input and output. So our aim would be the finding the efficiency of that. And for the refrigerator heat pump, those will come under work consuming, right? Refrigerator heat pump. So now coming to this question, what they have asked,
सर
we
ये क्या है सर एक बार ये बताना RAF by HP क्या है सर एक बार और बता दो सर ये
no, this is like nothing. Refrigerator and heat pump.
heat
Heat pump. That at the end of class you will know.
heat
Like
पे
that's why I came to here.
ओ
So
ओके सर
today we will go that point. So now coming to the we have to find the net work done per kg of gas. Okay. So what would be the net work done? Work done from the each process in the cycle, right? Hello.
Yes, sir. Yes,
Okay.
sir.
So how many processes are here?
Yes, sir. Yes, sir.
three process
Three processes are there, right?
three process
So
correct
first process is work from 1 to 2. Second process work is W2 to 3
2 to 3, sir.
and 3 to 1. So
3 to 4, 4 to 1, sir.
we will find the work from each process and add. Okay. So process 1. We will step by step we will go. So for the constant volume process, what is the net working hour?
Zero, sir.
Hello.
Zero, sir.
Zero, sir. Sir,
Hello. Hello.
zero.
Is anyone asking anything? Okay. So process from 2 to 3. Which process is that? Isothermal, right?
Isothermal.
Isothermal.
So here, what data we are having? Anyone? Here they have given initial temperature is 350 K. So this temperature is 350 Kelvin. Hmm? Apart from this, they haven't given anything, right? Hello.
Yes, sir.
Hmm.
Yes, sir.
So this is 350 K, and with
State.
this first point temperature is 350 K. So can anyone tell what is the temperature at point 2 T2?
So 3 times 350.
Sir, P2 is equal to 3 pi on what side?
What?
1050. 1050 Kelvin.
No. Someone is asking anything. What is it?
P2 is equal to 3 pi 1.
Okay. 3T1. So you know na, here I have already told you. Pressure with that directly proportional to temperature. So we are knowing the initial temperature. So we will be knowing the this temperature. So it will become 1050 Kelvin, right? And this is, and temperature for the point 3, it would be, hello,
Same.
same na? T2 would be same as
Kelvin.
T3. Okay. So for the isothermal, what is the formula for the work done?
PV, LN, P1 upon.
RT1 ln V2 by V1.
Someone is initially telling like P1, not one we will write here because it is from P2 V2 we will write. Okay. P2 V2 ln V3 by V2 because 2 to 3 we are going here. Okay. Or for unit mass we have to find. So M we are taking as 1. So we will not write R T2 ln V3 by V2. Okay. So R, anyone knowing, remember the value of R?
Sir,
8.31.
314 kilojoule per kg Kelvin.
Okay.
0.287 kilojoule per
Zero.
kg.
Remember these values.
Zero
Cp
point
is
two eight seven.
1.005.
Point two eight.
0.28.
Hello.
So
Hello.
value of R is 0.287 kilojoule per kg Kelvin.
Right. Okay.
सर पर यहाँ पर एयर तो लिखा नहीं है जो हम एयर का यूज कर रहे हैं.
They have said
Here
like
it
ideal
doesn't
gas,
have
nothing mentioned, then we have to take as air. Okay.
ओके सर.
Sir,
So,
they said ideal gas, sir. That's why we can assume here, sir.
if they have mentioned like ideal, if he mentioned the name of any gas or specifically mentions like Cp is this and gamma is this or R is this, then we can change. If nothing mentioned, then we have to take as air. Okay. So Cv is 0.718 and R is 0.287. So R we will take as 0.287, and because PV here we don't know, so that's why we have switched to this formula. And temperature is 1050 ln. So this V3 by V2, do we know or not?
Sir,
Yes sir, we know.
How you know?
sir,
Okay. Tell.
Because it's
sir,
isothermal process, so the V3 will be 3 times V2.
What are you saying?
Since it's an isothermal process,
sir,
so
Mm-hmm.
So sir, then P1 V1 P2 V2 equal to P3 V3 as P at pressure at 2 is 3 times pressure at 3.
Mm-hmm.
So volume at 3 will be
For
3
the
point.
isothermal, like PV is equal to constant, right?
Sir,
हाँ okay, tell.
hello,
हाँ हाँ.
hello,
Am I audible or not?
hello, sir,
Hello. हाँ, tell
Audible,
what.
sir.
sir.
Audible. You are audible.
Was not audible, sir. Was not audible, sir.
How this CP and CV? I get no.
What you say?
How? Sir, CP and CV. How we will calculate this CP and CV?
Actually, for air you have to remember these things. Huh? It is a constant for this. And for other gases you have to know, like for the formula of Cp is gamma times of R by gamma minus 1.
Sir,
Like that.
no, volume is not coming. Somebody is not put on their put off their. Sir, don't understand. Sir, what is this CP, sir? CP and CV, sir.
You know specific heat or not?
Yes, sir. Specific heat and this, I know.
Specific heat at constant pressure for that air is Cp, and specific heat at constant volume is Cv. So you are you there at
Okay.
the first classes or not?
Sir, no, sir, no.
So okay, we will ask that professor for uploading that recording,
Sir
so
ये
you
बंदा
might
बहुत
go there. Huh? I think so.
Sir, please tell every professor to upload their video so that we can recall.
Okay, okay, okay. I will say.
Sir, please share the PPT, sir.
Okay, that everything we will be sharing. Okay. So it will starting. It
Yes,
will
sir.
it may take time, but later it will be.
Sir, please upload in the website, sir.
I will ask in this weekly meeting. I will ask. Okay.
So can you kindly explain how we
Yes,
got
sir.
the isothermal charge?
What are you saying?
So for finding the isothermal work done,
Mm-hmm.
we have used RT2. No, sir?
Mm-hmm. RT2 ln V3 by V2. That I have written here,
Yes, sir,
right?
but an ideal gas is given, but it's not mentioned air, no sir. So how can we assume it's 0.28 cents?
No, no. I said like if they are saying nothing in the question, so we have to take as air that time. Huh? If they are saying like there argon gas or helium, anything is there, in that time we cannot take that Cp, Cv these values. If they nothing mentioned, then we have to assume like they are using air. Okay.
Okay. So is this the only way, like RT2, or we can use P2, P2V2,
P2V2 you
P3V3?
can use, but the pressure values you don't know. Na? Anywhere they haven't mentioned like what is the value of P2. What you will take?
Yes, you're right.
Nothing. Na? So that's why we have to switch to those formula which data we are having. Okay.
Got it.
So from here we will get V3 by V2 would be P2 by P3, right? And P2 by P3 is what? 3, right?
Sir.
Hello.
Hello.
हाँ.
Sir, CP value is not given, sir.
In question they haven't
Sir,
given
CB,
na.
CB will.
That you have to remember. That's why initial classes I told like you have to remember these things along with the course.
Hello, excuse me, sir.
CB value.
What?
Sir, can you
The CB value is not given.
Actually you write these values, okay? In later part also this will be the useful, right? So if air, you would have to remember these things. Air Cp is 1.005 kilojoule per kg Kelvin, and Cv 0.718 kilojoule per kg Kelvin, and R is Cp minus Cv, right? So 0.287. And for other anything other is there any other gas apart from this? So R would be the R bar by M.
Only mic is on, sir.
You can mute if
Sir,
you are asking anything, then you can unmute. Okay.
sir, someone mic is on, sir.
From your side, try to unmute. Okay. So if any other gases we have to find, then 8.314 divided by molar mass, kilojoule per kg Kelvin. And here Cv would be the R by gamma minus 1. R we will be finding from here, and gamma for that gas you would be knowing. Okay. So Cv you will find from here, and Cp would be gamma R by gamma minus 1. So these formulas you have to keep in mind. Actually I have derived all these, but initial part you would not be there, so it would be no, it would not be. So I will
सर
start.
सर 8.314 होती है सर, या हमें कैलकुलेट करनी पड़ती है सर?
This is
जैसे
the
ऊपर
constant.
तो आर की
You
वैल्यू 0.
here for the molecular mass of air, when you will put, you will get 0.287. Okay.
ओके, और सर नीचे जो आर की वैल्यू रख रखी है आपने
So
अदर
here
गैस में?
for that gas constant R value you have to put here, and gamma you will be knowing for that gas. Okay.
ओके
So point to
मींस सर आर की वैल्यू अदर गैसेस 3
your voice is not coming. Hello. Hello.
Yes, sir.
I think a network issue is there from your side. I'm not able to hear. Hello. Actually, can you ask this question from after the
सर
class? So I think a network issue is there. Hello.
Sir,
सर आई एम आस्किंग आर की वैल्यू, तो हमें अदर गैसेस के लिए 8.314 रखनी है ना?
Actually,
आई एम आस्किंग इज
you
दैट
learn only these things. You remember these things, and any other doubts after class we will see. Okay. After class, whatever you will ask, I will tell. So here R is written. You have to put for air 0.287 kilojoule per kg Kelvin, right? Remember this.
sir, work done will be 327.606.
1 minute. ln3. So 0.287 into 1050 into ln3. So calculate this.
So 331.
So 331 point. How much? Hello.
331.06.
06 kilojoule. Next unit. What would be unit here?
Kilojoule per kg.
Kilojoule per kg. You
Per
have to
kg.
answer. So two processes we have done, and for third process we are going. That is the constant pressure process. So for the constant pressure process, what is the work done formula? Pressure and 3 to V3 minus V1, right?
Initial temperature.
So here P3 V3 minus P1 V1, but we don't know the value of pressure and volume. So from the ideal gas equation we can write as R
RT3.
and P3 and P3 and P1 is the same, right?
Yes, sir.
So R T3 minus T1. Do we know the value of T3 and T1? What is T3?
No, sir.
Yes, sir.
1050
Yes, sir, we know.
We
minus
know, na?
105.
0 and
Here T3. T3 1050 and
350.
I think here 3 to 1 we are going, na? So V1 by V1 opposite of that would be happen, na? 3 to 1 we are going, right? Getting what are you saying?
Yes, sir.
So actually process is like this. Here we are going from 3 to 1. So final minus initial we have to write. Okay. So final point is 1 and 3. Here P1 V1 minus P3 V3. So according to ideal gas equation, we will write as R T1 minus T3. So R would be the 0.287. T1 is how much? 350. And this one is 1050. So what is this value? Hello.
Yes, sir.
Have anyone calculated this value?
Doing, sir. Doing just one.
Okay.
Minus 200.
Sir, minus
200.9.
200.9.
200 point.
On this space.
Kilojoules per kg. So all three processes now we are doing the work. So net work done would be 0 per second. How much? 331.06 minus 200.9. So after net work done, how much?
Minus 130.166 kilojoule.
130.16.
130.16.
16.
So here this is the simple question for the net work done. So now moving to the next question. So if anyone have not done, so you can see. Should I wait or try next question? There you take some time and then.
Sir, it's completed. Please proceed to next one.
So do next, sir.
Okay, I'm waiting for 1 minute by and right.
Sir, show the previous slide.
No, no, sir. Next question, please.
Don't worry,
Share the
you
PPT of
have
the previous class, sir.
Sir,
Sir,
please explain how we have taken V3 by V2 in process 2 to 3. Work done in process 2 to 3.
one minute. So this
Please explain it
formula
again.
you are saying, na? In process
Yes,
2
sir.
to 3, how we have taken P2 V2 ln with 3 by V2, right?
Yes, sir.
Sir, one more time explain, sir, from starting. Yes.
So here starting I am explaining again. So here three processes are there. They have given the initial temperature for the point 1. So process 1 is from point 1 they have constant volume process and temperature they have increased. If volume is constant, then its pressure only keep on rising directly proportional to temperature. So it here from here 1 to 2 temperature have rise from 350 to 1050, right? Understood?
Yes, sir.
So here temperature is 1050 Kelvin, and then from 2 to 3 it is isothermal process. And in isothermal process temperature would be constant. So along with the pressure, if pressure decreases then volume increases, like PV is equal to constant for the constant temperature process. So for second process is that, and here we have decreased the temperature till its pressure became the initial one, so at first point. So that till that point we have gone. So when the pressure reached at point 3 is same as the point 1, so that time again we have constant pressure process we have did and reached to the first point, therefore. So this is the
Yes, sir.
complete cycle. So three processes are there, so and we have to find the work done for each process. So first is the constant volume process. So for the constant volume process work done is 0, right?
Yes.
And
yes, sir.
then
Understood.
next one is the constant temperature process. So for the constant temperature is isothermal process. So for the isothermal
Sir, I have doubt one doubt in the previous question. Sir, according to second law, we cannot do work without without heat rejection.
Sir, sir,
According to
hello.
second, we
hello.
cannot do net work without rejecting heat. So in this
सर
cycle,
अदर
there
अदर
is no
अदर
rejection.
गैस अदर गैसेस के लिए सर अदर गैसेस के लिए जो आर की वैल्यू वो 8.314 होगी सर.
8.314 by m. This is it not visible?
हाँ सर, तो अदर गैस के लिए आर बार की वैल्यू ये सेम रहती है ना, ये पूछ रहा हूँ मैं।
हाँ, तो आर बार इज सेम ना, यूनिवर्सल गैस कांस्टेंट इज दैट, सो इट विल
ओके
बी
सर।
Sir, my doubt.
so here you are not calculating heat, you are not calculating heat doesn't mean na heat is not rejecting there.
But sir, can ये cycle possible हो सकती है क्या?
You can found the heat there would be heat rejection at the constant pressure process. Who is saying it would be rejecting? It would be rejecting at constant volume process. Heat would be the addition or rejection is happening there, and at isothermal process it is happening there. You are not calculating it. It doesn't seems like na it is not happening there. I am saying that.
Okay, sir.
Getting that? So in some questions later part you will calculating heat also. Here only work we have found na. In one question you cannot calculate everything. You can
Sir,
calculate,
but
but it would be the troublesome.
according to Clausius statement, without rejecting it, we
Don't worry, I
cannot
am
do.
coming. I haven't asked about Clausius yet. Na? So when we will be asking about Clausius, that time we will take care of that. Okay.
Okay, sir. ठीक है, sir.
Actually, your doubt after the end of the whole thermodynamics, you if you have any doubt, then you can show. Till now, only first law is going on. Na? So second law, how it will come into picture?
But sir, from that law, it seems infeasible
If
that
after
we
second
can't.
law you say it seems infeasible, then you say. Second law
Okay, sir.
haven't
Okay, sir.
you have read na yet.
Okay. We are just doing the calculations here.
Not calculation, it is cycle is possible. Calculation
Okay,
you
sir.
okay.
You
Don't
mean
worry.
this cycle is possible?
Cycle is there, so it is possible. You say you are saying heat transfer is not there. Heat transfer is there, but you haven't calculated. I said that. Okay.
Okay.
sir.
So read this question. So I am also reading along with you, so it would not take much time. So heat capacity at the constant pressure of a certain system is a function of temperature. So for the ideal gas, what we are considering? Cp and
It's a constant.
constant we are taking, right? With the temperature we are saying like it will not change, but generally it will change with the temperature only. Function of temperature we used to take, and in the thermodynamic property relation we will see like Cp and Cv will be changing with the pressure also. So for the ideal gas it will be the function of temperature only. So that they have said here at the constant pressure. At the constant pressure, uh, Cp is the function of temperature only and may be expressed as this is the expression they have given. So it is the specific heat capacity or the heat capacity. Can anyone tell what is the difference between the specific heat capacity and heat capacity?
Sir, it's per kg. Specific heat capacity is per unit kg.
So it is a specific heat or
Uh,
specific heat capacity or heat
capacity.
capacity?
It's heat
Specific.
capacity,
Heat
sir.
capacity written initially
Oh,
in this.
oh,
Na? So don't
in the
worry about the
question,
mass now.
not mention of mass of the.
It including mass. So when temperature is in the degree Celsius, we have to take. So the system is heated while it maintained at the pressure of 1 atmosphere, 1 atm. So pressure is constant here, and the value which they have given is 1 atm. Right? Hello.
Yes, sir. Yes, sir.
Yes, sir.
So until its uh, until its volume increased from 2000 centimeter cube to 2400 centimeter cube. So V1 they have given 2000 and V2 they have given 2400, and the temperature has increased from 0 degree Celsius to 100 degree Celsius. So what we have to calculate in first question? Hello.
Sir.
You have to calculate the heat interaction. What is the heat? Can anyone tell?
CPDT. CPDT.
हीट इंटरेक्शन मीन्स वी कैन से दैट कितनी हीट इंटरेक्ट हो रही है, मतलब कितनी हीट उसमें आ रही है
Heat interaction means
ऐसे चीज।
so CPDT. Why we have integrated here? Because here it is the Cp is the function of temperature, right? Hello.
Yes, sir.
Yes, sir. Yes, sir.
And temperature
That's
is in
fine.
degree Celsius from 0 to 100.
0 to 100.
So we will be integrating, right? 0 to 100 Cp 2.093 plus 41.87 by 200.
Sir, I have a doubt.
Yeah.
Sir, is there no constraint that in this particular formula we need to have absolute temperature, or we can have it in
And they have just
degree?
it's not constant. They just for the sake of the understanding they given like use temperature as degree Celsius. And in general, actual formula is used to be in the absolute only. It is just for the understanding purpose, right? Otherwise, the formula in the exponential and logarithmic everything is there. So that would be
So
the
need not
difficult.
convert it into
Nothing.
absolute
If they
temperature,
have
sir. We can
mentioned,
just keep.
if you mention T in that degree Celsius, and formula is also using small t, right? Hello.
Yes, sir.
If
Yes,
the
sir.
question is saying anything, then you have to follow that. If here I have put in like I have put like a capital T, and then you have to in whole thermodynamics you have to consider capital T as absolute and small t as that degree Celsius, right? So only that way we will go.
So for any process, what is the formula for internal energy change, sir?
That internal energy for you can go for MCVD.
So for this process, if we do Q equals to du plus W, here W is 0, then du equals to mcv delta T, no, sir?
Why W is 0?
Because, sorry, so volume not constant. Okay.
So for the constant pressure, as MCPDT is there, but M we are not considering because its CP value is taking care of that mass. Okay.
Okay, sir.
So CP and DT. So anyone integrating?
Yes, sir. We got 238. Sorry, 238.32 Joule.
238.
Anyone one or two more people can calculate.
Yes, sir.
Yes, sir.
Same, sir. 238.
238.32.
431.
Oh, what? 238. 1 minute. 238.32 joule. Another one. What you are saying? Hello. 400 something you are saying, no? Someone.
Sir, can you integrate for us?
Second part. If anyone getting a different answer, then please let me know. Huh? I am not calculating along with you. So I will show the process and simplify you can do. Integration is simple here. 2.2093 into 100 plus 41.87 ln here 200
221.
power and 100 given. So
431. Wow, sir.
what are we saying? So simplify this. What are you getting after simplifying this? It should not be 400, I think.
No, no, sir.
238.32, sir.
Okay. It because 200 from approximate here and it should be below the
Yes.
less than this 41. So this would be correct, I think. So now coming to the how much does internal energy of the system increase or decrease? So internal energy what is? What is the first law of thermodynamics?
Internal change in internal energy plus work done equal to total heat.
Energy
Del P is equal to
neither will gain
Nothing has
it's
created
quite
nor destroyed.
customary.
One
So
compound.
here we know the value of the heat interaction, right? From the here, but we don't know the what is the value of work done. So it is the constant pressure process. Work done for the constant pressure process is what?
P1, P
P into
delta
delta V.
P1
V2
V1.
P
minus
into
V1.
delta V simply.
P V2 minus V1.
So pressure we are knowing here 10 to the power 5 because 1 atmospheric 10 to power 5 Pascal, right?
Yes, sir.
1.1325.
Exact value we will take. Exact is 1.01325 into 10 to the power 5 Pascal. So when you will take this value, 1.01325 into 10 to the power 5, and what is the delta V? 400 into 10 to the power minus 6. You never forget to same match the same units, right? If you are keeping in the centimeter cube, convert into SI units. Always try to do that.
Okay, sir.
So what is the work done from here?
41.3.
How much?
40.53.
40.
Is after decimal you try to go to till two or at least three places, right? So because numerical answer type it might be some point of
Sir,
mistake or
sir,
so when now we are having the value of work done here and value of the heat here. So what is the delta U, increasing or decreasing?
increasing.
Increasing how much? How much increasing? Hmm?
Sir,
10?
sir, W minus Q equal to.
No, delta you have to find by delta Q minus del Q minus del W. Just simply. Q value we are having and W we have got from here. So we
Sir,
just take this value.
So W minus
197.79.
SQ.
This much it. So here nothing. Here we have to know one thing. If Cp value we are knowing, then how to get the value of heat interaction. We if now we have got the heat interaction value and the work done we have calculated. Then the change in the internal energy we will get, right?
Sir,
Hello.
Internal energy will
Yes,
increase.
sir.
So
sir,
internal
sir,
energy will increase.
sir,
Yes, sir.
So
how do you
it
solve
is
this
a bit
without calculators?
uh, easier question, so you can appreciate these type of question because in gate nothing will come like say they will simply give this Cp value that this formula they will give and try will ask you to find the heat how and add another part they will some work would be coming say calculate the efficiency of this cycle like that. So we will go
Sir,
with the conventional and later we will solve the gate question. Then
sir,
you will see like gate questions is a part of this only.
hello, sir.
Hello.
How do
Sorry,
you
sir,
solve
can you
without
please
calculator,
repeat?
sir?
Calculator you would be having na. I said like you have calculator.
Yeah, for exam, sir. In exam, gate exam.
Gate exam calculator was there na.
It's allowed, sir.
It's a inbuilt screen calculator would be there.
Okay, okay, sir.
Tell me about the whole 400 teams.
Okay, read this question first. Here in this question you try to go from basics and then easily it will be solved. Just read once. Okay, a spherical balloon of 1 meter diameter containing gas at one minute. So it has given like initial diameter at 1 meter and diameter containing gas at 200 kilopascal. So pressure initial pressure they have given like 200 kilopascal
200 K.
and the temperature is 300. The gas inside the balloon is heated until the pressure reaches to the 500 pressure. So they have final pressure they have given at 500 atmosphere. During the process of heating, the pressure is proportional to the diameter of the balloon. So what they said here, pressure inside the balloon is directly proportional to the diameter. Okay. Determine the work done by the gas inside the balloon. So we have to find the work done. So here which formula you are going to use?
P1 V1 by T1 equals to, we find volume, sir, by that. Temperature is constant.
Where it is saying, sir, temperature is constant?
Because it's balloon, sir,
Hmm.
we use atmospheric air to fill, sir.
So how will you know if temperature is going to rise or decrease? If nothing mentioned, if temperature is not written in the question, it doesn't seem like na it will constant.
Sir, volume is proportional to d cube. So we can make a relation between P and V so that we can make a process equation using this. It will
Sir, it
be
is a
P is
polytropic process, na?
proportional to,
One by one, tell. Huh?
yes, sir. So it will be P is proportional to
So you
V
are
power
saying like you just make the relation and tell what is the like you are saying
PV
like
power minus 1 by
you
3.
are trying to convert PV to the power is equal to constant, right?
Yes,
So here from here you will take the value of n then calculate the work done.
yes.
Excuse me, sir.
N is minus 1 by 3.
N minus 1 by 3, right? But
Sir,
what would be the value?
is this process is polytropic?
Every process you can convert to the polytropic. PV is equal to power n plus 1. So one way is this, but don't you think it would be the more tedious process because here volume, here diameter they have given. So you have to convert to the volume and constant value, and next here again volume you have to find like putting the value of final diameter, right? Okay, we will just try to solve and then your that process also we can take. So here they have said like pressure is directly proportional to diameter. Means P is equal to the, let's suppose one constant is there K. So we can easily get the value of K. Initial diameter they have given is 1 meter and pressure is 200. So 200 K or 1 meter. So K is here, from here how much? 200, right? Hello.
Yes, sir.
So
Yes, sir.
final pressure they have given 500. So what will be the final diameter?
2.5 meter.
2.5, sir.
2.5 into here. Here would be 2.5 meter. So now we will mark 2.5 meter. So what is the work done? Work done is PdV, right? Hello.
Yes, sir.
Yes,
Yes,
sir.
sir. Yes, sir.
So pressure, we know the pressure in the pressure is 200 into D.
Sir, relation of PV relation, sir, by Boyle's law. V1 by V2 equal to V2 by V1. Thus we get
Which
volume, sir.
Boyle's law follows? What is the Boyle law?
Boyle's pressure is inversely proportional to volume.
Where?
So we get a relation P1 by P2 equal to V2 by V1.
It is not
We have two
use our
pressures.
relation use anywhere. It is valid for only the isothermal process, right? Temperature is constant when. Where here it is written here, temperature is constant.
Okay, okay, okay.
Okay. So here pressure we know that in terms of diameter, right? We knowing the pressure and the initial dia and final dia we are knowing, and if we know the value of dV, change in volume in terms of diameter, for the sphere we can easily know na? Volume is equal to 4 by 3 pi r cube. When we convert r to dia, how much it will come? Pi by 6. It will become pi by 6 d cube, right? So dV would be into v square d of t. Any doubt till here?
So how you can write P equals to 200G?
Hmm?
P equals to 200G, how can you write?
Here we have calculated value of k na. K is 200. 200 unit also we inside. Kilopascal per meter. Okay, fine. So when we will write put here k is 200, because that this 200 we have found, they have given na initial diameter is this and relation they have mentioned. This is directly proportional to the diameter k. So from here we will calculate k and final dia with this relation we will find the final dia. So dV we are knowing in terms of diameter. So what will be the work done here? P pressure is 200 into V, and what is dV?
But sir, here pressure and volume both are changing, right? So you write work done equals to integration of PdV, but here pressure is not function of volume.
Pressure is function of diameter na. So volume also I converted to the function of diameter here na.
So okay, sir. Okay, sir.
So volume is pi by 2 dV. What is dV value? dV we will put take from here pi by 2 d square d of t. So from where to where we have to integrate? 1 to
D1
2.5.
से लेकर D2 तक.
1 to 2.5. 1 to 2.5. So simplify this. How much it will come? 100 by v cube into d of t. Right?
Yes, sir.
Anyone's calculate this?
Sir, it will be 2989.4.
Someone also confirm.
Yes, sir, it's 2989.4.
2.
2989.4.
Kilojoule.
Right.
So can we solve it by P1 V1 is equals to P2 V2
Actually, what P1 V1 is equal to P2 V2. What is this?
for finding V1 V2?
No, no, it is not right.
It's a general thermodynamic equation.
What is general thermodynamic equation?
So we have used limit of volume here 1 to 2.5.
Mhm.
I'm
We are
calculating
not
as a
mentioning the process.
V1 upon V2 is equal to 2.5. The same thing here.
What you are saying, PV is equal to constant, right?
Yes, sir.
Yes, sir.
So when it applies, you know the
How
ideal gas
how
equation.
how P is equal, sir? How P is equal to 200 into D?
अच्छा वही PV is equal to
सर
constant.
यहाँ पे P की वैल्यू तो है 200
PV is equal to
MRT.
MRT. When temperature is constant, M and R is constant for a gas, right? Hello.
Yes, yes, sir. This is general gas
Yes, sir.
equation.
M and R would be the constant for a gas, and when we will put the temperature as constant, means isothermal process. Temperature constant means what? Isothermal process, right?
Sir, here process is not mentioned. So,
That's why you are going to use that equation. That I am going to ask you. Na? PV is equal to constant here. You are saying we will use this equation here. Where mentioned like pressure, temperature is constant. That I am saying.
Sir, what if we find the polytropic index and then use the
Same thing
general
will happen.
formula?
Same thing. Same answer will come.
सर सर यहाँ पे P की जगह 200 इंटू डी कैसे आ गया, तो ये समझ में नहीं आया. डीबी की जगह ये वैल्यू डाल दिया आपने यहाँ पे, सर यहाँ पे.
DV. Anyone having doubt like how this DVH came? I will go step by step.
नो नो सर 200 डी, सर 200 डी कैसे
No,
आया
sir.
सर P की जगह?
So
P
this
is
this
equal
line
to
you have
100.
to read. Pressure is proportional to the diameter.
ओके 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 ओके.
So before asking now, twice read the question. Most of things are from there only. I have just told step by step. Instead of making question in between, just try to listen first also. No? Okay. Any other doubt?
Sir, I'm getting the work done as 2
Sir,
and
How much?
Sir,
I have doubt, sir.
Mm-hmm. Here, here.
Capital D is not given, sir.
What?
Sir, you have taken, sir, 200 D is equal to pi by 2 D square is not given, sir.
No, no. I have this calculated. I here what is the work done formula? General formula PdV, right?
Yes, sir, PDB, sir.
Pressure we knowing the function of diameter. This let's suppose this is the question one.
Sir, 100 by उसके जो you have taken, sir, D cube, sir.
No, no. 100 I have did from here. 200 2 divided by 200.
sir, but can you tell me, sir, how it can be solved with the PVN is equals to constant equation?
Actually, what is the work done from that? You mentioned PV to the power n is equal to constant. What will be the work done from here?
Um, P1
P1
V1
V1 minus
minus
P2
P2
V2 by n
V2 by
minus
n
1.
minus 1. Right.
One minute. Here only here you have to find the P1, P2, V1, V2. Okay.
Right.
So we are knowing the diameter,
Hmm.
initial diameter, final diameter, initial pressure and final pressure.
Okay.
So
Okay.
this upper part you can easily calculate. Here you have to calculate the diameter. Okay, 4 by 3 pi r cube or 5 by 6 d cube. Right?
Sir, and the value of n?
And I am telling.
Okay. Okay.
So here the pressure is the directly proportional to the diameter.
Hmm.
The voice not audible, sir.
Hello, audible or not?
Sir, it's audible, sir.
Yeah, it's audible.
So P
Sir,
will
audible.
would be the k here k will be the constant, right?
Right.
And the diameter d. So here what is the volume here? Pi by 6 d cube, right? So what would be the value of d from here? 6v by pi and cube root of that. Getting or not?
Yes, sir.
Yes, sir, yes, sir.
Yes, sir.
So so when you will that 6 by pi is also constant, right?
Hmm.
So
Yes, sir.
6 by pi to the power 1 by 3 and k, and here sorry, v to the power 1 by 3, this will be put, and this is again new constant, right? Hello.
Yes, sir. Yes. Sir.
Yes, sir.
Yes, sir.
So here what we will write, p v to the power minus 1 by 3, we take this side and this constant we take.
Okay, sir.
So here
Got it.
index we will take as v to the power minus 1 by 3, means n is equal to minus 1 by 3 and put here. So same thing it will be. This way also you can go, this is also easy, but that what I have used here, it is a general way.
Okay, sir.
So in this question he may ask you like pressure is proportional to the square of the diameter, cube of diameter, anything he can say,
Yes,
right?
Hmm.
Hello.
Yes, sir. Yes, sir.
yes, sir.
Yes.
So this is the, because then this way would be the most general way, what I have done here.
Sir,
Hello.
so you have written left side P directly proportional to D. Once discuss the relation, sir. How you get P is equal to 100 D?
Actually that
Sheet
initial
1.
diameter and initial pressure they have mentioned in the question first only.
Yes, sir. No, the relation you got is P is equal to 200 D.
Huh. So they
I'm
have
sorry, sir.
said here na pressure is proportional to the diameter of the balloon. So I have said P is directly proportional to D and P would be equal to KD when removing the proportionality constant. So from here we put the first boundary condition like 1 meter pressure is 200 kilopascal. So from here we got the K and put the that K here. So getting or not?
Yes, sir. Yes, sir.
Yes, sir.
Sir,
Yes,
please
sir.
can you show the previous slide?
Previous slide.
Sir,
Ah.
sir, also one other doubt, sir.
Mm-hmm.
Sir, like, once, show the question slide, sir. Sir, in the question I've seen, sir, actually the gas is a very low volume condition and
when you heat the gas, means when you heat the gas, it's going to expand, sir,
Huh?
inside the balloon.
It is heated,
Actually,
na? So
yes, sir. From initial to state to final state, the gas has been expanded, sir.
so you that is expanding, na? So how it volume will diameter of the balloon initially it is 1 meter and now it become 2.5 meter. It has expanded, na?
Yes, sir. Yes.
Huh. So not getting what are you saying actually?
No, sir. No, sir.
Sir, how
Nothing.
is the
I
value
want to.
PV came, sir?
Hmm? What are another person? What are you saying?
I didn't get how the value dV came, sir. Could you please
Okay.
explain?
This you know, na, this formula.
Yes, sir.
So if you derivate this volume from both sides, so how what it will become? dV is equal to pi by 6 is a constant. So if a d cube is there, huh? So d cube is there, what would be the derivative of this? D square into dd, right?
Yeah. Yes, sir.
So this is only written there.
Yeah, okay, sir. Thank you.
Okay, so we will go to next question. So I would say like you have to go from basics only, nothing more than that. Only here what we have used, only work done p dv we have used, nothing. Huh? So in this question I will give you hint and then we will start from the second law and two more questions I will give you from to try. Uh, I think that would be better. So here I will give you hint only for two questions. I will be giving hint and take the screenshots of those questions. Okay. Hello.
Yes, sir. Yes.
Yes. So what in this question he is saying? 1 meter cube of air is heated at constant pressure from 15 degree to 300 degree Celsius. So volume 1 meter cube and temperature 1 is the 15 degree Celsius and T2 is 300 degree Celsius.
Yes, sir.
So and first they have heated at constant pressure, that you keep in mind, and then cooled at a constant volume back to its initial temperature. This keep in mind, initial temperature, not pressure here. Hmm? Hello.
Sir.
Yes, sir.
Yes, sir.
The pressure is 1.03 bar. Calculate the net heat flow and overall change in entropy. So net heat flow we have to calculate and change in entropy you have to calculate. So two processes are there. TS diagram we will go. So anyone know how to draw the processes in TS diagram?
Explain, sir. Test diagram.
Okay, now I am starting. Then later I will ask. So what is
Yes,
the
sir.
constant pressure from 15 to 300? Like heating, then entropy will increase. Like this is the process from 1 to 3. Let's suppose. So this is the constant pressure process. Okay. Hello. So
Sir.
then
Yes,
then
sir.
Yes, sir.
then cool that constant volume back to the its initial temperature. So its initial temperature is this. So now I am here and now want to come back at point 1. So how we have to reach there? It is constant pressure and the next one is the constant temperature. Sorry, that one constant volume process. So whether should I 1 minute? I will draw the here.
Sir, area under TS diagram will give the heat flow.
That is there. I will draw one point here. Let's suppose this is 1, this is 2. So
Sir, for constant volume process, the slope is less than the constant pressure process.
1 minute. That's why I asked you how to go. So 1 to 2 here, and this is the temperature. So what would be the second process? Like here it will we should go, or we should go by this way.
The first one, sir.
I haven't mentioned now which one is first. This is the
First process, sir, because the entropy increases all the time.
Sir, two.
The entropy always increases, no, sir. So the
Yes,
first
sir.
way, sir.
Question, sir.
The first way is right,
I
sir.
am saying like first for the constant pressure process we are going from 1 to 2, and next we will be reaching the same temperature, but which way we have to go, from this way or this way?
Right side path, sir. Right side one.
In TS diagram,
So
slope of
what?
constant pressure is
Because the
Slope
entropy
of
increases, no, sir.
No, sir. Left side. Entropy decrease
The right
side.
side.
Slope of constant volume process is more.
How? Why?
Sir, right side, sir, because the entropy always increases, no, sir.
Someone said slope of that constant volume is more. Who? Why?
Swapnil, sir.
Huh?
Sir, because slope is equal to T by Cv for constant volume curve, whereas it is T by Cp for constant pressure curve.
dt by ds for the constant volume is what?
T by CV.
T by cv. And slope for the constant temperature at the constant pressure is T by Cp.
T by CP.
So Cv is always less than Cp, right?
Yes, sir.
It is clear, na? Cv is less than Cp.
Yes, sir.
So its slope would be more, because we are going anyhow in the temperature axis, we are going to the same drop, and for the making the slope more, we would be from this side. That's not entropy answer, because here we are not completing the cycle anything. So in processes you should not go like no temperature entropy will increase. It is simple process, not cycle, like for the entropy at the end it should increase. Entropy entropy we will study, okay? Then you can appreciate that part. Here slope for the pv, that pv and ts, I will at the end of class I will tell how to draw. So this is the constant volume process. So these are two processes. So now you will be knowing the value of the this here first a constant pressure process is there, and next the constant volume. So for both processes what would be the work heat transfer? For the constant volume is per unit mass you try to calculate. No. So tell per unit mass you have to calculate or what? So initially first you calculate the mass, how much air is there, okay? So it's your part how you will calculate. Use the PV is equal to MRT here. From here you will be knowing the pressure, volume, temperature, mass you will get. Mass will be conserved every time. So mass you will be getting from here. So then after getting mass, you can easily calculate the QV and QP with using MCP delta T and MCV delta T. Sorry, opposite. QP, QV, MCV delta T. Getting or not?
Yes, sir.
Hello.
Hello, sir.
So with this way you will use, and entropy formula I have already told to you. Do you remember or not?
Yes. Yes, sir.
Entropy formula for let's suppose we will number from process from here 1 to 2, 2 to 3. So by the way again I will giving the formula to you, then you try. Sorry, 1 to 2 and 1 to 2.
So the given pressure is initial pressure or final pressure?
Yeah, only initial they have given.
Okay, sir.
So entropy formula with the in terms of first is the constant pressure process. So for the constant pressure process, anyone remembers the formula? Means it involves the temperature and the pressure. So anyone knowing formula?
Ln T2 by T1. TPL and T2 by T1.
That pressure is constant, so another term would be the 0. So that's why we remove that part. So by the way, you remember it would be the helpful in later part also. So ln r ln p2 by p1. Okay. So but here p1 p2 would be same, so ln1 is 0. Okay. Hello.
Yes, sir.
And here cv ln t2 by t1 minus, sorry, plus r ln v2 by v1. So here volume is constant, so this part would be there only. So entropy, overall entropy, everything you can get, right?
Sir, I have a doubt.
What?
Sir, here 1 meter cube is given, volume is given, pressure is given, but like how to understand which pressure and volume is it, initial or final like that?
If they have told, first of all, what term is written here? 1 meter cube. 1 meter cube of air heated at a constant pressure from this. Means initially 1 meter cube it is heated from this to this, and at this temperature we are not doing anything. Just only except a temperature we are not doing anything here, right? So it is only initial one. Getting now what you are heating? You are heating 1 meter cube of air. Means the initial one is that, no?
Yes, sir. But about pressure, sir?
So first one is the constant pressure process. So at the second point pressure would be the same. Okay.
Sir, your mean 300 degrees Celsius is also initial temperature.
Your voice is breaking. What are you saying?
Sir, I am told I am sir 300 degrees Celsius is the temperature of initial temperature.
No. Initial one is 15. First point 15, second point 300, and the third point is the constant volume process. Then you have to calculate what would be there. Process you knowing na now.
Okay.
And temperature at the final temperature you are anyhow knowing this. Only initial temperature is that 15.
So one more small doubt, sir. P1 V1 by T1 is constant, no sir. It is applicable to all gases, no sir.
Yeah. If gas is there, then mass would be constant. If nothing you
So,
are leaking or adding, then mass would be the constant, and only with the addition of the heat or you are increasing temperature, volume will increase, decrease accordingly happen. Okay.
yes, sir.
Sir, can you explain the diagram once again?
Sorry. It is clear na, slope for the constant volume process would be more. Hello. Hello.
Yes, sir.
So if the slope of constant volume process, if you have suppose this is the constant, sorry, let's suppose this is the constant pressure process. So what is the change in the temperature value? This much means this much na, and you have to return back this point only again, but its slopes should be the more. So what is the slope? Perpendicular change divided by entropy change here, right? So if the delta t is same, if you have to increase this, so what would be the less? This should be less.
Yes, sir.
So if how this should be less? Initial one is this, so final one should be the less than this. Sorry. If this one is this difference is the initial one, so final one should be the less than the anywhere in between. I'm not saying like exactly here, but anywhere in between. Like here it will stop. Getting the why it is here? Because you have to increase the slope of the constant volume process. So that base should be the less. So delta S would be less for the constant volume process. Hello.
Yes, sir.
Okay. So
Yes.
try take the screenshot of this and try solving. So, exact value you will get there.
And sir, one thing, please repeat it again. Which one would be the less? CV value would be the less than the value of CP.
If you are not knowing, then try to know why. Okay.
Okay, sir.
Sir, sir, why do we want to increase the slope of constant volume process?
See here, temperature is the same. If the temperature is same both process, Cp would be more, so its slope dt by ds would be less. See this two equations now. If Cv is less, then its slope would be more. From this equation you will be knowing. And how this equation will be coming, that not that much to you, but if you want, then you can easily get from this, like dH is equal to Cp dt. Hello.
Yes, sir.
Sir.
Yes.
Yes, sir. You are audible.
Hello. I am audible now.
Yes,
Yes, sir.
sir.
Yes,
Audible,
sir.
sir.
So one equation you would have studied, like what is H? H is equal to U plus PV. So from here dH, what would be the dH? Du plus PdV plus VdP. So this would become dq, and for the reversible it will become TdS, right? So for the when you will take the constant pressure process, so VdP will become 0, right?
Yes, sir. Yes, sir. Now
So
I
and
got it.
what would be the dH? Cp dt for the constant pressure process, it will become Cp dt, right? Hello.
Yes,
Sir.
sir.
So from here what will become? What will be the return? Dt by ds at constant pressure
Yes, sir.
will become T by Cp. Actually, it need not to go that deep, but you may not forget by going this way, like that. But you have to remember these things. And for that, dq is equal to du plus pdv. Sorry, pdv. So for constant volume process, this is 0, and du is cv dt, right? And
Yes,
dq
sir.
is tds. So from here you can easily get dt by ds for the constant volume is T by Cv. Okay, so this is the simple question. You with three processes.
सर प्लीज पुट द मतलब पहले वाली स्लाइड खोलना सर एक बार ओके यू कैन चेंज
So this question also, it is, you have to create the cycle first, and then you can easily solve this question. So mass of the air, a certain mass of the air initially at 260 degrees Celsius and pressure. So they have given the temperature and initial temperature and the pressure. So with this, you can, from using the ideal gas equation, find the mass, right? Hello. And
Yes,
volume
sir.
volume also they have given here. With using these all three, you can find the mass here. And the air is expanded at the constant pressure. So initially it is the constant pressure process. PV expanded means volume will be increasing to the 0.084. First volume they have mentioned, and final second volume is also they have mentioned. A polytropic process with a polytropic process with n is equal to 1.5 is then carried out, followed by a constant temperature process which completes the cycle. Okay. Hello.
Yes, sir.
So with so two
Sir,
more.
you are not audible.
Hello.
Yes, sir.
Audible or not audible?
Yes.
No, sir.
We have to increase make
Audible.
here, we will make, okay, in between. So first we will go like this way. So from there, which way we can go?
Down, sir.
Down, right?
Yes, sir.
This you have to think, otherwise question will not be solved. like this it will go. Hmm. Why it will not go up above upside like that this way?
Sir, pressure is constant and as
Sir,
air
air
is
is expanding, sir.
and air
Then
is yeah. Then the volume would be
volume increases from here to here, no?
Pressure decreases.
Pressure should decrease, like this way. You have to think it will go up or above or not. So, and next second process is this, and the final process is what followed by constant temperature process to the complete cycle. So constant this way. So here we are having pressure constant. Here PV to the power 1.5 is equal to constant, and here what we are doing, temperature is constant, right?
temperature is constant.
So
Sir, excuse me, sir.
uh,
Sir, in the question, they said that only the air is expanding in constant pressure, no, sir.
but same air
Uh,
is everywhere, na? That
no,
is why.
sir. Once listen to me, sir. In polytropic process, he didn't tell that gas is expanding. It may have, sir, it may have gone up and uh, the next side,
Okay, okay, 1 minute. You are saying
continue the line towards
okay, 1 minute.
upwards.
1 minute. You are saying like it will go this and it may go this way,
Yes, sir. Yes, sir.
and then constant volume process. Constant volume. Then how? Because volume. Okay, like okay. Suppose this way. This way you are telling,
Yeah.
na? Anyhow, it will some slope would be there, but just suppose. This way you are saying, right?
Yes, sir. Yes, sir.
But when you read the question next, na, you will come to know why it will not happen. Actually, in the startup class, what I said, like this, if this cycle is the this what clockwise or anti-clockwise?
Sir, it's an anti-clockwise, sir.
Anti-clockwise, right? So
Yes, sir.
anti-clockwise means work absorbing cycle, yeah, work consuming cycle.
Yes, sir.
And when the second part you will read, na, then what it is saying, like find the efficiency of the cycle. So efficiency for which cycles you are going to calculate for the work giving means which work producing cycles we are used to calculate efficiency, and for the work absorbing cycles we used to calculate the COP, right?
Yes, sir.
So with the efficiency we come to picture it comes to your mind like you should go this way. That's why if you not ask this question this time, later I will tell. Later I should be telling like you should go only this way.
ACW means, sir? ACW.
Anti-clockwise. Getting what why it has gone
Okay,
this way.
sir. Okay, sir. Okay.
So you will be knowing everything here, like sketch the PV and TS coordinate. You try. Uh,
Sir, please,
Hello. What are you saying?
please explain process 2 and 3 on the PV diagram once again.
It is nothing. It is the you have to go clockwise, na, because it is saying efficiency here. So you cannot go opposite way. If you will go opposite way, then the cycle will become anti-clockwise. So it is the work absorbing. So
No, sir.
this way you have to go.
Upper diagram, sir.
Okay, 1 minute. This you are saying, na? Hello.
Yes, sir. Yes, sir.
So it is just simply first process is constant pressure process. Second one is the PV to the power 1.5 is equal to constant. Index you are knowing. If you are knowing index, you can easily find the work done, heat transfer, everything, right?
नहीं सर, जो आप कह रहे थे ऊपर क्यों नहीं जाया गया, नीचे क्यों आया, ये वाली बात.
If this is this way and you are going upside, then this should be like this, okay? Not this much. It should be less than that. Like this way it has gone, okay? 1 to 2 and 2 to 3. And now constant temperature process. Let's suppose this is constant temperature. So this is anti-clockwise cycle, right?
Yes, sir. I
सर
understand.
हेलो सर, आपने जो कांस्टेंट टेम्परेचर लाइन बनाई है सर, सर इसका स्लोप इस तरह से तो नहीं है ना सर?
अरे वो
Sir,
स्केमेटिक
like
है भाई, स्लोप तो सबका एवरी स्लोप वुड बी द डिफरेंट फ्रॉम दिस. Just change this way you will come. It is this way.
नहीं सर, फर्स्ट की तरह स्लोप नहीं है टेम्परेचर कांस्टेंट का.
Actually, you should not go think that way. That temperature slope you are not able to make that way. This will not happen. For the refrigeration cycle, we will make this cycle. You have to take care of that time.
sir, if it may be in the second case, the point 3 should be on the left side of the point 1, sir. Then it
That's
will
why
be easy
initially
to
I rubbed
yes,
that
sir.
part.
Then it yes, sir, yes, sir. Then it will be easy to connect to the one like the
It is
same
not
way in
easy. Actually, that will the theoretically it would be wrong if that we will go beyond that. If we are going beyond that,
no, sir. How it will be theoretically wrong?
then you are decreasing the then you will be
Then it's
increasing
the
pressure,
process will be
increasing pressure.
isothermally
Yes,
expanding, sir.
yes.
Then
You will be
parallel.
the increasing the pressure and sorry, decreasing the
Yes,
pressure.
sir.
Opposite that will happen, right? Okay.
Yes, sir.
Okay. You try to solve that way. And don't think. So first this easily you will get the coordinates of all. Okay, because you are knowing all values, right? Mass you will get from here, and for point 1 pressure, temperature and volume you are knowing. So it constant pressure process. So everything you will know for the point 2 also, right? Hello. Or should I do? I think you should
Yes,
try once. Actually, I will do, but you should also give a try if you are getting anything. Okay,
yes,
so
sir.
let's
We will try.
you will try, but next class we will start from here, and two more questions are from this way. This we have already done in next class. So two questions are left only. So this question take screenshot and try to do and try to find efficiency, because in the efficiency part you have to take care of the heat. What is the efficiency? Net work done divided by heat input to the cycle, right? So for each process you try to find the work done, and for each process you try to find the heat input, and then only where in those processes where you are giving heat to the system, those process you have to consider here downside. If a cycle is rejecting heat in the any process, you should not take that into consideration, right? What I'm saying. Anyone have doubt?
Only heat input.
Heat input in those processes where we are giving heat to the cycle, that should come in bottom side. Q input, see directly I have written that because that's why.
Okay, sir.
Sir,
So
how can we draw the TS diagram of this process?
actually I intentionally haven't drawn. I would like to that you should give a try. Hmm.
Yes, sir. Yes, sir. Definitely we will try.
Because that question I am solving next time anyhow. Hmm.
Okay.
So
So
can you share the previous week's PPT?
actually I am doing everything in this PPT only. So whenever we will be sharing, then I will share this PPT directly.
सर वो पहले वाली स्लाइड खोलना जिसमें रिटर्न था रेड रेड से रेड पेन से. नहीं सर, ये वाली नहीं, सो जो आप बीच में खोल लेते हैं. नहीं, नो नो नो, इससे पहले. हाँ, यही यही 2 मिनट
So can you show us the
सर. दो.
previous week's derivations? We could take the
ये
screenshot.
सर हो गया सर.
What
हो
is
गया
it?
सर, हो गया.
So previous week's derivations, sir. It would be helpful.
सर ये 34 it is.
No, I'm not seeing anything.
Sir, could you please share with us the previous slide before we have not attended the previous lecture? So can
Actually,
you?
na, with slides you may not get the things, because I used to write only that time. So I will share. I have not issue anything because I have not directly point to point. I have writing. So if some points you are not getting, then you have to tell me. Like here, I have written this way.
Sir, sir, please, sir,
Tell.
sir, 2 minutes. Sir, please put on the sir these PPTs one by one, so that I can take the screenshots.
I will be sharing this PPT. Okay. No problem.
Sir, how you will share, sir?
1 minute.
How?
I am sharing the link and there I will upload this PPT. Okay.
Okay.
Here in the
Okay.
chat box, I am sharing the link.
So this video available in website or
This video will be coming, but as of now, it is not available.
when it available, sir?
It available in your website, sir.
What are you saying?
The video, sir.
When it uploaded?
Video will be uploaded, but actually NPTEL team is working on that to uploading that video and some folder they would be making like that. So it would be in the same portal, I
Later on,
think.
sir. So later on.
Not later. Soon it will be happening.
Sir.
1 minute.
Sir, where will be the drive link, sir?
That I'm
Drive.
sharing 1 minute.
Sir, where will you share, sir, this one?
1 minute. Link I am putting in the box, chat box.
Chat box, okay. Sir, if you prefer any other others books, can you tell me, sir?
Actually,
For
for
preparing
GATE, you should
GATE.
not go for book, I think. You should try previous year question and question you try to solve. Go if you are you which year of you in your graduation?
Final year, sir, final year.
Final year, na? Then you should try more questions, I think now.
Okay, okay.
Actually, if not that much fluent, na, then you should go with 1 minute. Here I will make one folder and there will. Okay, this is a link I have shared. So I will put PPT here. Okay. Hello.
Yes, sir.
It is telling that no items are there.
I
No
haven't
items are
uploaded
found.
yet, but I will be uploading there.
Okay, 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 sir. Okay.
So from next class, I will give you some previous year questions in
File is
the.
not showing, sir.
Huh?
The file is not showing, sir.
Actually, I haven't
The
uploaded
PPT.
this na yet. It is saving yet. It is taking some time, I
Yes,
think.
sir.
Sir, but you have to give permission,
Sir,
right?
today's
Sir,
class
on
is
Monday,
over.
sir.
Sir,
The next
today's
class.
class is over.
Yeah. If you are fine, then I can go with the entropy part. I want to start today actually that part, but initially some time has gone.
Class is on Monday, sir.
What?
Sir, on next Monday you can start. No?
Yeah, it would be better because most of people have gone. So from next Monday, I will start from entropy, and there we will solve some questions because
Okay, sir.
good question from there we will take. And I
Okay, sir.
used to prefer that I will after this I will take a 20-30 question of gate previous year, and in the slide I will put that I want to share to you. So
Okay,
with
sir.
And just this PPT also you can you will share, no?
yeah, I will share this also. That I will put in that slide only.
Sir,
See
any
that link only. There I will tell.
sir, any books
Mm,
for preparation?
previous year book you are having or not?
No, question paper is available, sir.
Oh. So any coaching book you can order na online.
It's okay, sir. For coaching book, it's okay, sir.
Yeah, yeah. For previous year is same na.
Sir, the coaching books for theory is good or not, sir? Like
Actually, for
theory
the
books.
gate point of view, I would not say it is very good because it for the you if you are going for the means conventional type questions also and everything, then it's fine. But for the coaching, for that workbook they used to give one, na?
Yes, sir. I have the workbook and the previous year.
Uh-huh.
Okay.
So with that workbook, it is
So the lectures from NPTEL is better, sir. You're saying.
NPTEL is also better, but in NPTEL actually it is for the means I am saying if you haven't gone once in that part, then you go for an NPTEL and completely because NPTEL is for the basic fundamental everything is there. Huh? And for
Yes.
the gate it is supposed to be like you have done that part, so you have to go through with more questions and all.
सर मान लीजिए कोई स्टूडेंट है, उसने 4 साल पढ़ाई नहीं की। एक सर नॉर्मल सा क्वेश्चन है सर मेरा, मैं अपने को लेके चलता हूँ, जैसे 4 साल में उसने कोई पढ़ाई नहीं की, बस उसने पास होने के लिए एक दिन पहले उसने रट्टाफिकेशन किया थोड़ा बहुत, फिर पेपर देके पास हो गया सर वो। सर क्या वो स्टूडेंट भी गेट को क्लियर कर सकता है?
Okay, one example I will tell you. One of
है सर?
the this year this gate 2022 na, I have given in 2020. So one of my friend from the gate 2020 that time his rank was I think 9,000. 9,000 even I think that he is not qualified that time, and his in BTech his I think 9 backlogs are there. Hmm. And
हाँ
Sir,
Yes.
the link you shared is showing that it is empty.
huh?
Link you have shared now, sir, in messages.
Link I
It
will
is
put
showing empty.
it will be showing empty. I will put there. So that guy in gate
लिंक
2020
सेव
have
नहीं।
got sixth rank. Okay, so don't worry about that.
सर नहीं सर, मैं ये पूछ रहा हूँ, जैसे सर मेरी जैसे सर मैं अपना एक्सपीरियंस बताऊं सर, मेरी 9 बैकलॉग्स थी ऑल ओवर ईयर, मतलब ऑल ओवर 4 साल में। और सर मैंने कम से कम अबाउट 18 पेपर्स दिए हैं सर। मेरे को कुछ नहीं मीन्स मेरे को मैंने 4 साल में कुछ भी पढ़ाई नहीं की, मतलब एक रात पहले पढ़ाई की और पेपर देने चला गया, पास हो गया। तो सर क्या गेट का पेपर क्वालिफाई इस साल कर सकता हूँ? जैसे सर मेरा बीटेक खत्म हो चुका
Mm-hmm.
है सर, है सर।
Okay, you ask me. I will give you mail here. Send mail. I will. We will talk there. Okay, it will be better. I think.
ओके ओके सर, प्लीज शेयर योर मेल आईडी सर।
If any problem, then you can share to me. That I will help whatever I can do. Okay. No issue.
Is there any Telugu guys here? Telugu speaking.
Hello. Sir, I want to
Yes,
ask
I am
a
Telugu,
question.
bro.
Bro, can you share your number here once? I will WhatsApp you.
Sir, can we leave?
Yeah, yeah. I am uploading in that link. I will upload that PPT, and next class we will start from the entropy, and those two questions will come. Okay.
सर
Sir, I want to ask a
सर
question,
एक
sir.
और चीज सर, जैसे मीटिंग एंड हो जाएगी तो सर ये वाला तो लिंक भी गायब हो जाएगा
So link you have
सर,
copy
तो हम
link
कैसे दोबारा से?
copy that link na, copy that link and put somewhere else.
सर कॉपी सर कॉपी नहीं हो रहा ना ये लिंक, कॉपी नहीं हो रहा ना सर ये लिंक। दिक्कत तो यही आ रही है ना, that the link has not been copied.
सर देख ऐसा कर, उस लिंक को ओपन कर, उसके बाद ब्राउजर में ओपन होगा, वहां से कॉपी कर ले।
Okay,
मुझे
wait a minute.
हेलो सर,
Okay.
Sir, I want to ask
So
you.
can you show today's slides, the screenshots?
Hello.
Sir, during
Yes, sir. Can you show today's slides, the
I have
screenshot?
uploaded in that link. You can see from there.
why there is pressure drop?
Yes, sir, it is visible. Sir, it is visible.
What are you saying?
Sir, during throttling, why there is pressure drop?
During? Hello.
Throttling, sir, throttling.
Okay, okay.
याद है भाई कैसे कॉपी करना है कैसे बताया था आपने
ब्राउजर खोल वहां से कॉपी कर ले
ऐसा है भाई
ब्राउजर में खुलेगा वहां से कॉपी कर ले
हाँ ब्राउजर खुल गया मेरा
वहां पे वहां से कॉपी
So someone is asking anything. What are you saying?
sir during throttling why there is pressure drop sir
Okay. So in throttling, what happens?
कांस्टेंट में उसको रोकने की कोशिश की जाती है
I am not asking what happens. ऐसे ऐसे कर let's suppose we are making. What happens?
सर एनपीटीएल इज कांस्टेंट
Okay. So let's suppose this is 1 or this is 2 or this is 1 or this is 2. Which will one? Let's suppose again process is coming. So we will give A name here, B name here. So which one you will take? A or B? Which
सर
one?
आई
B, sir, B.
बट आई डोंट
Your voice is not coming. Someone has asked question. No?
सर
B, sir.
Means I am asking about which is practically possible or feasible. Okay.
सर ए
Why not B?
B, sir. Throttling means cooling, no, sir. Heat rejection means entropy decreases.
Actually, throttling is constant enthalpy process. Okay. So, but throttling, do you know it is irreversible process?
ओके सर सर इस चीज के बारे में हाँ 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 ओके सर
Throttling is irreversible, right?
हाँ हाँ सर सर पर ऐसा क्यों है इरिवर्सिबल क्यों है
Throttling actually one dh equal to tds plus vdp. Okay.
यस सर
So here dh would be the 0.
यस सर
So
TDS is not.
And here what happens na in throttling minus vdp would be there, okay. And in throttling pressure drops or increases?
सर मेरे को वही चीज
एक मिनट we will you text me you mail me in that whatever mail id I have given na mail me I will share link to there
okay
there to you.
okay sir okay
Here
sir
you have to put
sir
in
can I leave now
हाँ okay you can leave. So here you can see
yes, sir.
hello hello
Yes, sir.
so here you have to consider like that throttling as a throttling as irreversible process, okay. Irreversible where you consider that temperature would never be 0 and ds would be the positive, right?
सर वो हम नहीं कह सकते सर ये पढ़ेंगे सर आप
तो अभी हमने थ्रोटलिंग भी नहीं पढ़ाया ना इसमें तो व्हाटएवर आई एम सेइंग दैट यू कंसीडर
सर सर
तुम्हारा योर वॉइस इज नॉट ऑडिबल एक्चुअली ना सो हेलो
मैं तो बोलूंगा मैं तो मेरी तो पढ़ाई है मैं धीरे धीरे अपनी तैयारी कर रहा हूँ हाँ हाँ
हेलो
ठीक है चलो सर मैं तो चला।
हाँ हेलो सर। Am I audible? हाँ सर। सर मैंने ये पढ़ा है कि सराउंडिंग प्लस सिस्टम इन दोनों की एंट्रोपी इंक्रीज करती है, सिस्टम की डिक्रीज भी कर सकती है एंट्रोपी।
Throttling, why you are taking a system? Throttling process is means you have to consider about that where throttling device is there and what impact of surrounding is there. Complete you have to take care of that. Okay, TDS. That
ओके
DS I
सर।
am asking about. So
हाँ
this DS and temperature both will be the positive. Okay.
ओके सर।
So minus sign is there and that specific volume would be the positive. So how this minus when dp is the negative, then only it would whole as a whole will become positive, right?
ओके सर। सर सर प्रेशर डिक्रीज करता है तो टेम्परेचर क्यों डिक्रीज कर जाता है?
हाँ?
प्रेशर डिक्रीज करता है तो टेम्परेचर क्यों डिक्रीज कर जाता है?
That's simple, you can see now. U is equal to MRT. If pressure will be decreasing, then temperature should decrease. In this equation, you can see. This is simple, but exactly that equation that time may not follow. Okay, but in this way you can appreciate like it may decrease.
ओके सर। हाँ हाँ ठीक है सर। ओके सर, थैंक यू सर।
Any other question then? Hello.
यस सर, थैंक
Yes, sir. Okay then. If not anything, then we will start entropy from next class and see. Okay.
Okay, sir. Thank you, sir. Thank you.
Then fine. Thank you. Good night.
Good night, sir. Good. Bye, sir. Thank you. So, sir, may we leave now, sir?
Ah, you can leave. By the way, I'm ending the class.